Can you explain it to me?
Sure. One sec. Okay. Okay. Hello. My name is Carla. This is Alex. This is Mario. This is Matthew. And we're here to tell you about fusion. This is what our exhibit depicts. Okay. So what do you know about nuclear fusion?
Nothing really. I don't know.
Nothing really. That's okay. So we see fusion happening every day when we look at the sun. Because we have a sun, we know that fusion occurs. Okay. So fusion involves these are two hydrogen atoms. Okay. Fusion involves the colliding and fusing, combining of two hydrogen atoms. Okay. So let's talk about how close these are. Let's move these a little bit further apart. Yes. Okay. So these atoms, these hydrogen atoms, are relatively far apart, right? They have a lot of room to move and pretend they're in a really big room, and it's just them two. So they're under low pressure. They're not crowded together, they have a lot of room to move. Okay? And if you see the red lines and the blue lines, okay, those signify high temperature, low temperature. Yes? Okay. Now let's talk about the motion of the two hydrogen atoms at high temperature and low temperature. Do you think they're going to move fast or slow at high temperature?
At high temperature, they move fast.
They do move fast. You're very correct.
Had to recall my science.
That's great. At high temperature, the two hydrogen atoms are going to move really fast because they're rather uncomfortable. That's how you can remember it. Okay? And at low temperature, they'll move really slow. So let's test low pressure, high temperature. Okay? Do you think they're going to collide and stick?
At high temperature?
Yes.
Yes.
Ready? Okay, 1, 2, 3. That's made my water.
Okay.
Let's try low pressure, low pressure. So the blue line, yes. Moving slow. Ready? 1, 2, 3. Nothing. Now let's try high pressure. So now the atoms have been transferred over to a smaller room. Okay, and it's just them two, and they don't have very much room to move in. Okay, and now let's test high pressure. Yes, high pressure, high temperature. The red line. So at high temperature, are they moving fast or slow?
They're moving fast.
They're moving fast. Good. Do you think they're going to stick? I think they're going to stick. They choose to stick. Let's see. 1, 2, 3. They stuck. Holy moly! You have just seen nuclear fusion in a model. Yes. These two hydrogen atoms have collided and combined, and they have fused. They have made a little mini sun. Okay. Now let's test. Let us test high pressure, low temperature. Yes. And at low temperature, are they going to move fast or slow?
Slow.
Slow. If you think they're going to move slow, let us see. Do you think they're going to stick?
Yeah.
Do you think they're going to stick? Okay, we'll see. Mario's going to show us.
Okay.
Yes.
Oh.
Holy moly, they did not stick. And I'm not sure if you noticed, but there is a slight repulsion going on. If you'd like to come up and feel, young man. Okay. You need your two hands. Yeah.
And vice versa, right?
So grab both of the atoms, these are hydrogen atoms, grab them, okay? And try to put them together slowly, and tell me if you feel some sort of repulsion as you're going.
What makes it a little
Just keep going. Do you feel it? Ooh, you feel it, right? Okay, so these are the two positive sides of the hydrogen atom, right? And as we recall, positive and positive, they don't go together, right? It's always positive and negative. Yes. So because they were moving slow, that repulsion is still taking place. The positive and positive is not going to want to go with the positive, yes? But when they're moving fast at high temperature, that's red, okay? When they're moving fast, the speed that they're traveling at, it kind of throws the repulsion thing out the window. That's why they stuck. Did you see them stick? That's why they stuck. So, fusion took place at high pressure, high temperature. And you can remember that by saying high, high. Say high, high. High, high.
Hi, hi.
High, high. Yes, high, high. High, high. Those are the conditions under which fusion takes place when it takes place. Because we also remember that fusion doesn't take place all the time. Yes. Also, once again, my name is Carla, this is Alex, this is Mario, this is Matthew, and our exhibit is on nuclear fusion and how it involves two hydrogen atoms colliding and fusing together under the ideal conditions, which are high, high. So you can remember that nuclear fusion takes place at high pressure, high temperature. Yes? High, high. Wonderful, and that is our exhibit.